Good morning, ladies and gentlemen. I want to present your report, Optimal Control with Prediction for the Process of Vacuum Membrane Distillation. Authors Bogdan Korniyenko, Lesya Ladieva, and Oleg Bereza. One of the possible options for renewable energy is the use of bioethanol biofuels. To concentrate bioethanol, it's effective to use the process of vacuum membrane distillation. Membrane process is relatively new and one of the most effective ways to separate multi-component mixtures. Membrane distillation has many features compared to traditional separation methods, such as low operating temperature of the process. The solution to be separated must not be heated to boiling point. A mathematical model of the process of vacuum membrane distillation is proposed and investigated. A control system has been developed using the methods of analysis and synthesis of predictive control model, control system based on mathematical optimization methods using predictive models. The method is chosen because the membrane change its properties over time and can provide better control of the process over a long period of time. The system is automatic control for non-stationary dynamic object based on the MPC controller, and a PID controller with fuzzy logic are compared. In recent decades, there has been tendency in the world to significantly increase the production of ethanol to solve energy problems. Its use as biofuel. Membrane distillation designed to recover alcohols, its technology that uses porous membranes to separate a liquid mixture where the drying force the process is the pressure gradient on the membrane. The main advantages is ability to constantly remove ethanol during the production of fuel alcohol. Membrane distillation is membrane process of thermal transition in which the main role is played by hydrophobic microporous membranes that separate the heated stock solution and the cooled permit pass. The passage of ethanol through the pores of the membrane can be generalized in three stages. The formation of vapor layer at the boundary of the hot rough materials, the transition of the vapor pass through the microus membrane, three condensate of stream of the cold side of the membrane permit. In vacuum membrane distillation, the driving force is maintained by applying a vacuum on the permit side. The applied vacuum is less than the equilibrium vapor pressure. The ability to work efficiently at low temperatures makes the membrane distillation process the utilization of low-grade, vast and alternative energy source. Here on the slide, you see calculating scheme of the process of vacuum membrane distillation. Here you see mathematical model of the vacuum distillation process, equation of the dynamic of the heat balance of the ethanol evaporation process for accumulating capacity of molasses channel, equation of the dynamic of heat balance of the condensation process of ethanol for the storage capacity of the pyramid channel, equation of the dynamics of the heat balance of the transfer from the condensation process of ethanol to the refrigerant, equation of the dynamics of material balance for the accumulating capacity of the molasses channel, taking into account the changing in the concentration of ethanol in the molasses solution and the vapor diffusion through the membrane. The essence of MPC approach is the following schema of control of the dynamic process on the principle of feedback. A mathematical model of the membrane distillation process is considered the initial conditions for which is its current state. With a given control, the model motions are integrated, which gives forecast of the object motion at a certain finite period of time. Optimization of software control is carried out in order to bring the adjustable variables to the forecast model closer to the corresponding set signals on the forecast horizon. Optimization is performed taking into account the whole set of constraints imposed on regulatory and adjustable variables. At the stage of calculation, which is depicts a small part of the forecast horizon, the found optimal control and measurement of the actual state of the object and end stage is realized. The forecast horizon is shifted one step forward, and points 1 and 3 of this sequence are repeated. We use the control problem with a linear model and quadratic functionality. Let the control object be described by a linear system of different equations of the form. To access the quality of control process, a quadratic functionality is introduced. Here on the slide, you see experimental study of the optimal control system with MPC controller. Here on the slide, you see transient characteristic of the membrane distillation process with MPC controller. Here on the slide, you see automatic control system with fuzzy pit controller. The task of optimization is to minimize the functionality that plays a key role in setting up adaptive and optimal control system. Functionality for optimization has the form. Here you see schema of operation of the pit controller in the MATLAB Simulink environment. And finally, graph of the transient process of the adaptive pit controller in comparison with the MPC controller. And conclusion. The process of membrane distillation in bioethanol production is considered. The work is developed to solving the problem of designing and researching the control system of the vacuum membrane distillation process. In vacuum membrane distillation, the drying force is maintained by applying vacuum and permanent side. A vacuum of less than equilibrium vapor pressure is applied. Condensation occurs outside the membrane model. Analysis of previous work has shown the process of vacuum membrane distillation in the production of ethanol for biofuels, and the model of process is insufficient research. Existing models are difficult and sometimes impossible to apply in control systems. Therefore, a mathematical model of the dynamics of mass and energy transfer in the process of ethanol separation using vacuum membrane distillation for control papers has been developed. The pressure is the permit channel was chosen as the control effect. This paper is developed to the comparison of control system for vacuum membrane distillation using MPC controller and pit controller with fuzzy logic. The development control system must maintain a given concentration of ethanol in the solution at the outlet of the membrane model, which in turn should ensure the desired quality of the source material and the normal course of process. The paper presents the transition characteristic of the control systems of the vacuum membrane distillation process. As can be seen from the graph of transient, but system reflects the value of concentration of bioethanol in solution at a given level. A system for order different equations was used to synthesize controller with predictive model, and transfer order function was also used for fuzzy control. It is worth noting the process with the MPC controller reaches a fixed value much faster than adaptive pit controller. A lot of the overregulation of the adaptive pit controller is less. Given the rapid development of bioethanol production technology, in the near future, this approach may become one of the regional methods of managing membrane distillation process. Thank you for the attention.